Welcome to Let's Get to the Marks. This question is about the preparation of an alkene from an alcohol. So we've got 2,3,3-trimethylbutanene. We're making it from 2,3,3-trimethylbutanol. Once again, pause the video, have a read through all the information, then unpause and watch the walkthrough. All right, let's get into this. So the preparation is done by heating the alcohol. That's the 2,3,3-trimethylbutanol on the left, with the concentrated phosphoric acid that acts as a catalyst, and you get a kind of dehydration reaction and you form 2,3,3-trimethylbutanene, which is an alkene. Now we've got the distillation equipment. It's how we separate out our reactant from our product. We've got the alcohol and the phosphoric acid and anti-bumping granules in here, and we've got water in at the bottom, we've got water out at the top, and we've got the Liebig condenser there, and of course the vapors condense down there to form 2,3,3-trimethylbutanene. The distillate's collected in the range of 77 to 82, and the question is, explain why the water should enter the condenser at the bottom and not at the top. So let's take a little close look at this diagram. Water comes in at the bottom when you're doing distillation, and the water goes out at the top. Now, why is that? Think about the hot vapor is moving down the inside of the condenser, and the cold water is going to move in the opposite direction, a bit like the countercurrent flow mechanism in a fish gill. If you're an A-level biologist, this ensures maximum efficiency of heat transfer between the hot vapor and the cold water. Basically, the hot vapor is always passing fresh cold water, so you've got a bigger temperature gradient and more heat transfer. So also, the water filling in from the bottom ensures that the condenser completely fills with water, because it pushes the water all the way up to the top. So we want to say ensures the condenser fills completely with water, maximizes the efficiency of heat transfer is another mark, or maximizes, yeah, that's fine, the efficiency of heat transfer between the water and the vapor. And this ensures that all of the vapor condenses. Now, why do we want that? We don't want any of the vapor not to condense and to escape, because then we won't get all of our product. Okay, 7.1. Name the complete mechanism for this reaction. We got this reaction here where you can see there's a hydrogen ion from the phosphoric acid, and it's going to the alcohol, and it is the lone pair from the hydroxy group on the alcohol is being donated towards the hydrogen ion from our phosphoric acid catalyst. So can you complete this mechanism? Pause the video, have a go. Okay, I'm going to go through it. I'll do the name afterwards. It's easier to talk about the name afterwards of the mechanism. It's always easier to draw out the mechanism first. So what we have first of all is a bond forming between the OH group and the hydrogen ion. That leaves 3 bonds around oxygen. You get an oxonium ion. When you get an oxygen atom with 3 bonds, it becomes like an oxonium ion. So you put a little plus on the oxygen. Now this is unstable, so in order to stabilize, and that's going to get you the mark called M2 in the mark scheme, out the 4 marks. Now in order to stabilize this, the bond here between the carbon and oxygen is going to break and donate the electrons to that positive charge on the oxygen atom in order to stabilize it, and that is your M3, so another mark you get for the mechanism. Now you can actually combine these 2 drawings. I'm going to draw it out again to make it a bit easier, but you can combine the 2 drawings to get all 3 of the mechanism marks. So what happens now? We've lost our water and we've just got that CH2 left behind. But the CH2, because it lost the pair of electrons to the oxygen atom, it's now positive, the carbon there. So what happens is a hydrogen atom breaks off and donates its electrons to stabilize it, and we get a double bond forming. You can actually combine these and put these both on the original drawing, which I'll show you now by adding in. So to the original drawing, I've added a little blue arrow and a plus if you wanted to combine and not do it as 2 separate drawings, but I prefer the 2 separate drawings, but you could combine all in one, as I just showed you there. Now, what you can see, that will get you M4. We could have added that in over here on the original drawing. And you might notice that water is being eliminated. So what's the name of the mechanism of this reaction? It's an elimination mechanism. So we just call this elimination, and it's purely because the water is being eliminated. Notice that hydrogen ion that breaks off in the second part of the reaction shows that the phosphoric acid is a catalyst, because we're reforming that hydrogen ion from the phosphoric acid. And so the name of the mechanism is elimination, and that's your M1 mark. So that's how to get the M1, M2, M3, M4 marks. 3 for the drawings, 1 for the name, which I always do the name afterwards, because you'll find a clue to whether it's substitution, elimination, or addition from the drawings. Now I'm drawing the final product here, the alkene. You do not get any marks for drawing the final product. They assume you could work that out easy peasy, not worth the mark. So then we got our double bond, and lovely jubbly. That's what the final product would look like. It's an elimination reaction, dehydration. We've removed water. And there we go. Right, let's move on to 7.3. In a similar experiment, 12 centimeter cubed of 233 trimethobutanol MR116 produces 6.12 grams of 233 trimethobutanene, an alkene. Calculate the percentage yield. The density of 233 trimethobutanol is 0.818 gram per centimeter cubed. So we've been given density, which means we're probably going to use the density calculation. And we've also been given the MR, and we've been given a volume, but we haven't been given concentration. So we're probably not going to do N over CV. And we've been given percentage yield, so we're going to need that. So you're going to need several calculations here. One of them is definitely going to be mass over density times volume. You should know that off by heart. When you're given density, you'll normally have to do that. And then we're going to also have, oh gosh, I put moles over MR. I meant to do mass over MR, or Mr. Moles with mass at the top. You get the idea. Yeah, M over MR times moles, probably the most common equation in the whole of A-level chemistry, that second triangle I've drawn there. We'll have a quick look at the reaction. Let's whip to the reaction. It's a 1-to-1. Look, the alcohol to the alkene's 1-to-1. That might be, we might need that in this equation as it's a moles one. You generally need to know ratios. So let's go through and zoom out a little here to give ourselves some working space. And let's go through and crack this final part to the question. So let's use the density first of all. So we've been given the volume of the reactant, which is the alcohol, and we've also been given the density of the alcohol. Remember, it's an alcohol becoming an alkene. So we've been given the volume and the density of the reactant alcohol. So what we can do, we can use that density and that volume. 12 centimeter cubed is the density, times it by the volume. That's why you have to know this equation off by heart. 0.818 times 12. And that is going to give us our mass of our reactant alcohol that we are actually starting with. And that works out as 9.816 grams. So, and that's going to score you your first mark for working out the mass of the alcohol that we've got at the start. Now we can work out the moles of alcohol that we've got. We know that we've got 9.816. We've been given the MR is 116. And so we can actually work out the moles of the alcohol that we've got if we wanted to. Now remember that percentage yield, we're going to need this for the final part of the calculation, is the actual mass over the expected or maximum theoretical mass. So you can either call it expected mass or maximum theoretical mass. Well, we know what the mass of the alcohol is. That's neither our actual or theoretical mass, but it does allow us to work out the moles of the alcohol, and then we know it was a 1-to-1 reaction. So by working out the moles of alcohol, we know what moles of alkene of 233 trimethobutanol we should produce. Awesome. So do 9.816 grams, which is the mass, over the MR of 116, and this will give us our moles of alcohol that we expect to make, and that's 0.0846. That's our moles of alcohol. Now we know it's a 1-to-1 reaction, so that's the moles of alcohol used. As it's a 1-to-1 ratio, I'm expecting us to make 0.0846 of the alkene. When we dehydrate it with the phosphoric acid, we eliminate the water as we did above in the mechanism earlier, we should make 0.0846 moles of the alkene. Now all we need to do is work out the MR of the alkene, and we can do the MR times the moles, and we can find out what our expected theoretical maximum mass of alkene we should have produced. So let's do that now by doing the MR times the moles. Now the moles is 0.0846. Now we need to work out the MR. Well, the formula of the alkene, as it is 2,3,3 trimethyl, so it's got 3 methyl groups, that's 3 carbons, and bute, and it's an ene. That means there's 7 carbons, C7. Remember the formula for alkenes is CnH2n, so just double the number of hydrogens. So C7H14, which has a 98 MR. So our alkene has an MR of 98, so times that by the number of moles we should make, and it tells us that the expected mass is 8.29 grams. So what did we actually get? We actually got 6.12 grams. We should have got 8.29 grams. So we do 6.12 divided by 829 times 100. Bob's your uncle, Fanny's your aunt, 73.8%. Boom! There we go. And that's for our 5 marks. So we'd have got M1 here of the 5 marks for working out the mass of alcohol reactant we started with, basically solving the density equation. Then converting that into moles of alcohol would be M2. The ratio is 1 to 1, so that's also our moles of product. And from there, you can work out the MR, the expected mass, and the percentage yield. All right, guys, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks. I'll see you on the next vid.
You're still here? It's over.